Okay, welcome back. We are now on problem 4. So a lot of times you're going to get a problem, eyes up here, eyes up here, eyes up here. You're going to get a problem where you're not really sure how to start. And you're just going to try something. I decided there's stuff going on the left and the right. So I decided to start on the left with my reciprocals. And I wrote cosecant is 1 over sine. Once I did that, it looks kind of yucky. Both in the numerator and the denominator, I have got a fraction with a denominator of a sine plus 1. The denominator of that 1 is a 1. I can't add those two fractions together because they have different denominators. So what I'm going to do is I'm going to multiply through both the numerator and the denominator by sine of theta. I can't just multiply through the numerator by the sine of theta because that changes the value of the expression. But I can multiply through the numerator and the denominator by sine. So what happens is we have sine over sine. So when I multiply it's like, there's a parentheses, by the way, around every numerator and every denominator. People don't write them, but they're there, and you've got to know that for calculus. Calculus teachers every year complain about students not knowing that. There's a parentheses around every numerator and every denominator. So when you're multiplying across, this is sine times 1 over sine, that just becomes sine over sine. That's a 1 minus sine. Hey, it's the same thing as the right side. And the denominator, when you multiply sine times 1 over sine, that's sine over sine. That's just a 1. Plus sine times 1 gives us sine. So this becomes 1 minus sine of theta over 1 plus sine of theta. And it's equal to the other side. I know I'm standing right in front of the work. I'm going to move in just a second. Check. Questions about this algebra? It's distribution. That's all we're doing there. That's number 4. Questions on number 4? We're going to move to number 5. Number 5 is pretty short if you can immediately identify the Pythagorean property that 1 plus tangent squared equals secant squared. All right, I'm erasing. Still have time for this next problem. All right. 1 plus tangent squared of x equals secant squared of x, and sine squared of x. These are the Pythagorean properties that you've got to know. So the first one I'm just going to use the way it is, and I'm going to substitute in secant squared for tangent squared plus 1. Okay, now the second one's just a little bit trickier. This one says cosine squared minus 1. Okay, well, I gotta manipulate this next property just a little bit. If I subtract 1 from both sides, I can get my cosine squared minus 1. But then I have to move the sine squared to the other side, and it becomes negative sine squared. So cosine squared minus 1 equals negative sine squared. So I'm going to substitute in for cosine squared minus 1, negative sine squared. This is the reciprocal of 1 over cosine squared times negative sine squared. I'm forgetting my equal signs. There we go. This is like over 1. I don't usually write my over 1, but that's what it says. This becomes negative sine squared of x. Oh my gosh, that's an x. Over cosine squared of x. Hey, isn't that negative tangent squared? negative tangent squared equals negative tangent squared. This is messy. But notice I'm working on the left until I get my left side to look just like my right side, and then it's verified.